Okay, so today we're going to start with content, some introductory comments that will help us really think more in terms of the physiology that we're going to talk about this semester. So at this point, did you just get here?
No, I didn't see the paper when I came in.
Okay, I'll get it for you right after
Okay.
class.
Okay.
Just remind me. So far, we've talked through some basic introductory things about inorganic ions. I wanted to emphasize to you the importance of cell membranes and the movement of charged ions across cell membranes. That was a big topic. The second big topic was the structures of the organic macromolecules. And so with each of those organic macromolecules, I wanted to give some context for anatomy and physiology. So for example, with the carbohydrates, you're thinking energy production, and you're learning the basic, the 3 6-carbon and the 2 5-carbon monosaccharides. You're learning the monosaccharides used to build the 3 major disaccharides. And then we looked at lipids, and I told you about 3 varieties, and then I gave you some context, right? It's a steroid, it's a lipid, it's made from cholesterol. Where did it come from? And so you know about the hormones of the adrenal cortex and the gonads already. You've been introduced to that. Okay, so I gave context for the organic macromolecules, and I gave context for cell membranes and the movement of charged ions across cell membranes. Okay, now, at this point, we're going to talk about the major concept in anatomy and physiology, mostly for the physiology stuff, a concept known as homeostasis. Homeostasis was a term that was coined by a very famous physiologist named Claude Bernard, and Walter Cannon was involved in some of the early writing about what's going on in the human body in terms of balance. I'm not interested in the historical perspective of these guys. They're always mentioned in AAP books, and that's why their names are here. What I'm more interested in, you learning, is conceptually, what do you mean when you say, excuse me, what do you mean when you say homeostasis? So, here's a simple definition. Homeostasis is the regulation of the body's internal environment. The regulation of the body's internal environment. We think about this, or we should think about the regulation of the body's internal environment as physiological, functional things that are happening inside of me that I don't have to think about. So when we're thinking about homeostasis, when we're thinking about regulating the body's internal environment, we really need, right up front, to delineate between the major divisions of the control systems in our body that actually do this. Now, the 2 big ones, and I'm going to give you a few examples of this, the 2 big ones that regulate the body's internal environment that are responsible for homeostasis are the nervous system and the endocrine system. Now, most people know what I mean when I say nervous system. A lot of people don't know what I mean when I say endocrine system. The endocrine system is the hormone system in your body. So the combination of the nervous system and the hormones within your body explains homeostasis. These are the two regulatory systems within human bodies that are responsible for maintaining the body's internal environment. Now, when you think about this regulation in the nervous system, we are going to see two major areas of the nervous system, two major areas that are involved in making us work. For homeostasis, we should think about one of those. So let's learn them both now, the terminology for them, and we'll pick this up more as we go. The nervous system can be divided into two major divisions. They are voluntary and involuntary. So, for example, your voluntary nervous system is the system that makes your skeletal muscles contract. This is what we consciously do. So when you think voluntary, you're thinking about movement. That's coming this semester, but not today. The nervous system I want to emphasize to you today is the second division, the involuntary nervous system. The involuntary nervous system is called the autonomic. Do you hear automatic in that word? Autonomic. The autonomic or the automatic nervous system, the involuntary nervous system. And there are two major divisions of the autonomic nervous system. They are sympathetic and parasympathetic. Sympathetic and parasympathetic. Now, as we're progressing in this class, voluntary and involuntary functions of the nervous system, as we're going through the voluntary nervous system, the point of this class is going to be to teach you what are the structures of your brain and what are the pathways from your brain that go to the skeletal muscles to make them contract. That will be the main focus of the voluntary, or sometimes referred to as the somatic, S-O-M-A-T-I-C, the voluntary somatic nervous system. That is not today. I'm just introducing it to you. That will be a major content area for this class. When I'm done with you, you should be able to say something like this. I want to make the bicep contract. Here's what happens. A signal is initiated in the precentral gyres of the cerebral cortex. And the neuron there has an axon that extends out of the brain, through the brainstem into the spinal cord. And it makes synapses with the ventral horn of the spinal cord in the lower cervical regions. These regions are part of a plexus of nerves called the brachial plexus. And those axons then, after synapsing, pass along the ventral roots into the spinal nerves. And in the spinal nerves then, in C5 and C6 and C7, they become a major nerve passing through the shoulder called the musculocutaneous nerve that delivers information to the bicep. You see what I mean? We're going to do this in this class. Walk me through the pathway to a particular muscle. Where are these nerves? Does it matter that I know where this nerve is? Well, sure it does. Okay, so that's coming in this class. For today, we want to think about internal body regulation. This is an autonomic phenomenon. This is either parasympathetic or sympathetic. Autonomic function. Now, get the definitions straight. They never go away. In anatomy and physiology, you have to know these forever. The sympathetic nervous system is for fight and flight. It deals with stress, fight and flight, stress. That is sympathetic. The sympathetic nervous system does fight and flight, stress responses. The parasympathetic nervous system is rest and digest. It is the nervous system that is active when I'm not fighting and flighting. The human body was designed in order to live in this world, the parasympathetic world. If you live in a world where stress and fight and flight dictate your physiology, you are going to have all kinds of physiological problems. And I'm going to walk through some of those with you in this class. The big emphasis there in the sympathetic fight or flight damage to us will come in the second semester when we're doing hormones. Okay, Parasympathetic is where we're supposed to live, rest and digest. The system was designed to be most of the time in a resting condition where the heart rate is down and the blood pressure is down and the digestive system is working. Rest and digest, this is parasympathetic. All right, so there are your two major divisions of the nervous system. Somatic and autonomic, voluntary and involuntary, and basically what they do. Today's class is focusing in on the autonomic nervous system, all right? So already you've got some context. When I say autonomics, the first thing a student should think is there are two divisions that are regulating all of this, and the one I want working most of the time is parasympathetic. This is what I want happening most of the time. Okay, so as we talk about some of these structures and examples, as we're going through this, you're going to go, I got you. I see what you're talking about. All right, so the major brain structure that we know is involved in regulating autonomics is a little structure in the bottom of your brain called the hypothalamus. And the hypothalamus, by way of innervations, nervous innervations, through the autonomic nervous system, has access to a plethora of downstream structures, including skeletal muscle. The hypothalamus should be thought of by anatomy and physiology students as the major control center for the autonomic nervous system. The regulation of parasympathetic and sympathetic information can be traced to the hypothalamus. So it is that's why it's written here on this slide. It is a major control center. And we will talk much about hypothalamic influences on the human body this term before we're done. Now notice the hypothalamus has access to your skin and blood vessels and sweat glands and even skeletal muscle. It's got a lot of access. Okay. So I'm going to use it, since it's real information, I'm going to use it as an example to talk to you about homeostasis. All right. So let's put this in categories. As it turns out, there are three different basic mechanisms by which the body's internal environment is regulated. Homeostasis is accomplished by three major mechanisms. Now, for those of you who are reading, and I encourage you to do so, reading in your book about this, you will discover that Merriam only mentions two. So, I'm going to talk about a third, and then I'm going to let you decide as to whether or not the textbook should include this one. All right? I believe there are three. You can make up your mind about the third as to whether you believe me. Okay, the number one mechanism for regulating homeostasis is this one, negative feedback. In a negative feedback system for the human body, a change in some variable is resisted. Now, there are really easy examples of this in real life. So we have a thermostat on the wall. We set that thermostat's temperature to 72 degrees. It's watching now the temperature. The variable is the change in temperature. So as the temperature goes up, the thermostat responds by kicking on the compressor so that the system will blow cold air in the system and cool it off. That is a great example of what we mean when we say a negative feedback system. And it's on a slide coming up. I'm going to show it to you again here in just a second. Repeat myself. Okay, so negative feedback is the number one way of doing homeostasis in the human body. There are control centers. The hypothalamus is an important one. And there are others that are monitoring things in my body. And when something happens, these control centers initiate phenomenon to resist that change. Now, the two examples